next session. Let us sincerely welcome Professor Yang for delivering the session about open source security challenges, solution, and opportunity.
Yeah.
Yes, it's yours.
Thanks. Yes. Thank you, everyone. Thank you very much. I was really amazed for the Max presentation and the live demo, which is very, very interesting and talking about the future of the software development. I think this talk, I will probably give you a slightly different kind of aspect or angle about future software development from a more negative side, right? And when you see the live demo of the chat GPT, you can see the capability of the tools are generating the live code based on your question, interactive and generating meaningful things. But on the other hand, when you talk about the precise actions and looking to the challenging things of the security analysis, or even the security or robustness of AI model itself, this is a big challenge. So in the future software development, you will benefit from all these kind of tools, AI assist kind of development, but still something you cannot run away, that is cybersecurity. So today I'm more focusing on this open source security and give you some idea what is the state of art of the security problems and what are things we could do and what are the future opportunities. I think open source, I think PinCap is like a very great example of open source company. And now we have a saying, it's called the software is eating the world. But actually there's a second sentence, which is called the open source is eating the software, which is very much true if you look in the statistics. So for most of the applications, 60% to 90% of the code are actually open source. You are no longer build any application from scratch. Probably you look for some kind of possible code and framework in the GitHub. And the number of open source is growing in a phenomenal speed. Like every day we have 100K of release, and by 2026 we have a 300 million open source library out there. But it's not only about number, it also comes with the great complexities, because every one open source library, they are probably using another 8 other open source library on average. I think if you're looking the TiDB library, it's probably using 100 of different other open source libraries. So this is the issues. But more importantly, the things I want to say is that the open source is not completely free. In the sense is that you think you're just using the open source, but actually you have to pay for its security. Because open source software is another software. It also have vulnerabilities. It also have the potential, the kind of malicious code inside. So when you are using the open source software, you need to make sure you are not inherit all the vulnerabilities in the open source library in your own code. Otherwise, you will be hacked. And every 1 in 4 data breaches actually are done through open source vulnerabilities. And further beyond, it's not only about the vulnerability, you also have the potential license problem, because when you are using some of the free open source libraries, this open source library, their license will not allow you to use it for commercial purpose. But if you're not aware of this kind of constraint, and you may violate it, and you may got a kind of letter from the lawyer. And this is no longer the kind of some simple data or the kind of the things I want to scary, but there are many incidences in the last couple of years, like the infamous OpenSSL's Heartbleed kind of vulnerability. This year, they have Log4j or Log4Shell, which is probably one of the critical open source libraries which affect the whole industry. And these are the real things, but the interesting things I want to share with you is that when you're facing some critical open source libraries, to fix this, it is actually very, very difficult. The reason is that if you consider the Java ecosystem, right, like a big building, the Log4j kind of library, these are the kind of very common library which is used basically by any Java projects. So if you're looking at the big building, the Log4j is probably sitting in the level 1 or level 2 of this Java building. And when you have a hole in level 1 of your Java building, which means the whole building can easily collapse by a tiny vulnerability. So this is the impact of this kind of open source security vulnerabilities. But the challenge to detect and fix this kind of vulnerability is far beyond the imagination. Because when the event happens, really the whole security world is panicking, because every security expert in any organization is start to looking for the Log4j usage in their application and try to see how can I find all the possible Log4j and fix it. But actually the thing is very difficult. I give you some kind of a very concrete reason. First, when you're looking into Log4j in your application, you are not only looked into the direct usage of Log4j, but you need to also look into the transitive dependencies. Because if you are using open source library A is using B is using C is using Log4j. So you need to do the complete transitive dependency analysis in order to find Log4j. So this is one thing. If you're lucky, you are not using any of this Log4j, but your application or your developer may use some third-party binaries. You are building a big website, you just grab any useful binaries into your website and use it. And this binary may contain Log4j. So to detect all possible Log4j, you need to not only to do the source code analysis, but also you need to do binary analysis, which is a much more difficult problem. And then the third scenario is everything you're using is fine, have complete Log4j free. But if when you are deploying your application into the Docker, into your Docker environment or the cloud environment, they may have Log4j. So to do a complete examination, you need to not only examine your code, but also the environment, which become a much more complicated task. And this is actually lead to the bigger problem we call the software supply chain concerns. Because software, like open source now, is really like the physical software supply chain. You have the developer of the open source component, and then it is linked with your CI/CD pipeline to compile the open source into the libraries, and these binaries can be distributed through the package manager, and the package manager will store the binary into the cloud, and essentially the final developer is using this open source library through the cloud container. And every step in this software supply chain can introduce vulnerabilities, backdoor, and contaminate the whole thing. A very simple example, we did some very interesting experiment. We put some kind of malicious code in the CI/CD script in the GitHub, and the people have completely no idea. They just copy paste this CI/CD script, and this script actually is able to generate malicious code. And then this malicious code can be injected into all the popular libraries. And the package manager can also be hacked. They can replace all this benign open source library with a malicious one. And this malicious library can go into the software development pipelines. So these are the concrete things actually happening in the world. And you really need to understand the complexity of the whole software supply chain to deliver high quality and secure solutions. So this is, I think, the real challenge. But the bigger things, when we talk about open source security, it is a kind of massive space. When we started looking to the research and the productization of this open source security, we found this is actually very, very difficult problem to address. The first thing, to find all the open source library and its corresponding vulnerability and manage them, the first thing, you need to build a vulnerability database to include all the open source library related vulnerability. But this is actually a tall order. The reason is that there's no central place which provides all the detailed and accurate information about vulnerability in the world. There are some very important databases like NVD from US, CNVD from China. People try their best to collect the vulnerability information, but the information there is not accurate. A very simple thing is that when you find the open source vulnerabilities in a particular library, you want to know exactly what are the versions of this library are affected by this vulnerability. But this information actually is very difficult to obtain, because when the hacker, when they found the vulnerability, they just report and get a bounty. it is not their responsibility to check all the previous versions of this library, which of them are affected by this library, because it's a difficult thing, and nobody is able to do the confirmation. And when this information is wrong, and all the scanning tools in the world to provide this kind of open source security scanning is not able to work correctly. So you need to really have a foundation to build a comprehensive and accurate vulnerability database. So this is one big challenge. Second thing, when you are giving me a software, can you have a tool or algorithm to find all the possible open source library accurately? This sounds simple because if you're using Maven, you can say, oh, I give you my POM file, you can do a simple POM file analysis, then you can find all the open source library. But actually, as I mentioned earlier, there are many ways to introduce vulnerabilities in your software. You can use the POM file, the package manager through the POM files. You may copy paste some of the open source code into yours, and which is very common. We did some simple statistical analysis. For C project, Java project, more than 50% of the code in most of the C and Java project are actually duplicated from the open source. So they are not only using the POM, the package manager, but they are also copying the code. So to do a precise open source analysis, you need to do POM analysis, you need to do source code analysis, and sometimes you don't have source code, you need to go to the binary and the container. So that actually create a lot of interesting research problem to be addressed. And the third thing, probably is even bigger topic, is that every application you worry about your own code, but actually the government or the society is not only worried about one or two open source library. They want to understand what is the things happening in the open source ecosystem. How many important library like Log4j are there? If we know there are 100 or 200 Log4j library out there, we should try our best or all the possible resource to protect them. But nobody is telling us how many critical libraries in the open source ecosystem. All we know, in Maven package manager, there are close to 500,000 open source library out there. But which are the 500,000 are critical? Nobody knows. So it is very important to understand what is happening in the open source ecosystem and find the critical one and protect them. So this is what we call the weak link and the fragile points. And the last thing is all the kind of a longer vision of the society is that when you are using any open source library, we hope that it is protected by security. And we don't need to worry about vulnerability. I can just grab and use it. How can we achieve this kind of trustworthy open source? So this is also a very important kind of direction. So to address this thing, so this is the things I throw out the question, the challenge, but we have done quite a bit of research in the last couple of years to try to address different things. I think today this is maybe too much technical. I may just talk one or two of this. If you're interested, you can look at the research papers, but I can tell you this is actually a very important research area. I think we need to put a lot of effort in order to understand what is kind of the status, right? So here, maybe, I think this is maybe an interesting work I can share with you is that we spent quite some time to figure out how to automatically find the affected version range for a particular vulnerability. So we can do a kind of a very detailed code clone analysis to see when you give a vulnerability, whether this vulnerability exists in a particular software based on the kind of similarity matching. But not only that, we are able to find this patched version of the one when you change the code quite a bit, but still you have vulnerability inside. We are able to do this kind of matching with the kind of the code change, right? So this is the one thing we found. This is very, very interesting to help the world to build a comprehensive and accurate vulnerability database. So this is some kind of binary open source analysis work we have done, and now it's part of engine. I think I will skip this, but this is maybe something interesting to share is that when we start to sell some of the tools we developed to the potential customers when do the presentation, and typically there are many questions is that GitHub have open source software which is doing similar things. And another company A and another company B have similar product. Why should I buy your product, right? Can you give me the reason? So I was quite frustrated when I faced this kind of question from the customer. And I'm trying to give an answer more from the kind of professor kind of aspect is that it's difficult to tell them I have these features or that features, but I think the best way to convince them is that if you're looking at the result, if you're looking at the accuracy, right? When I give you a very concrete benchmark with all the ground truths, you try all the different tools and you see which one is the best. And I think that is probably the best way to convince the customer. And this is exactly the things we did in this research paper, trying to understand when you want to find vulnerability in the software, what is the right benchmark for different kind of programming language? What is kind of the right setup in the different phase of the software development lifecycle? We found it's very interesting. Most people think when they have a software vulnerability scanning tool, they can use this tool in any time of their software development process, right? Even I have my code in the GitHub, I just download it and scan it. But actually, there are many important assumptions when you're using different tools, because some of tools require the compilation. Some of tools require particular kind of setup. But the user of these tools, they have no clue. So they are just looking at the features. They don't understand when to use which right tools. So the kind of understanding and precision understanding is really not there in the current kind of DevSecOps world. So what we are trying to do is that we want to teach everyone what is the best tool for which language and when you're using it in the which phase of the software development lifecycle. So this kind of knowledge is very, very important when we're using any software assistant tools. Like the ChatGPT, right? You need to understand this tool may be good for Java programming, but when you go to the Go or the new programming language, when you develop a Solidity, they may not able to give the kind of accuracy you have. So this is the very important understanding you need to have in order to use the right tools. And maybe I talk about this work. I think this is a very, very, I think, interesting work we have been working in the last 3 years, is that we want to understand how many important libraries in a particular open source ecosystem, like JavaScript is NPM, Java is Maven. For C, there is no package manager, so this is a difficult thing. But what we are doing here is that we reverse engineer the NPM package manager. We find out all the dependencies of the open source package and build a graph database of these dependencies. And this dependency actually can help us to understand what are the critical libraries which are dependent by many other libraries. And then we attach the vulnerability information into these libraries. And then we can study what is the security situation about the open source ecosystem. And the result is really scary because we found 16% of the JavaScript library, their latest version, have vulnerabilities. Which means if you are using any of these 16%, the latest version actually have vulnerabilities. And when you are using it, your software will have the same vulnerability. And another one is 40% of the vulnerability will never be excluded from the ecosystem. Because this library have vulnerability, many other library is using this one. But when you have vulnerability reported, other library are not going to update the dependency to the newer version. So the vulnerability of this library will be keep they exist in the ecosystem and affecting all the other libraries. So this is the kind of the reality. And imagine most of the software are dependent on this open source and how dangerous the world is, right? When we talk about this, the software is the infrastructure of the future life, but the open source is infrastructure of the software. And then you have tons of vulnerabilities in the open source, and they are there forever. And what is kind of a security situation about the software, right? So this is just to give you some kind of idea about the future software development. If you're not spend time taking care of the open source, the things, whatever wonderful things you're building will be essentially sitting on the risky foundations. So, so I don't want to dive too much about the research the algorithm, but actually share with you some of the ideas, examples we are using on this topic. But there are many things to do. What I mentioned just some of the research, but we have a big research team in the university keep working on different language, different kind of related problem. But one very much related things I want to share today is that since Max is mentioned about this AI, actually we have spent quite some time trying our best to use AI to find unknown vulnerabilities in the code. So we are actually working very hard, try to come up with different ideas to encode the vulnerable function data into some kind of interesting neural network. So we tried all the different kind of neural network, LSGM, graph neural network, a gated graph neural network, pre-trained model, transformer model, all of this. So we got some interesting results, but at the same time, we found when you're applying AI, it is not easy. The reason is that why the ChatGPT you feel is quite comprehensive, is quite useful, because they have a large amount of data. But when you are using AI in a very small or niche problem like vulnerability detection, you find that you are not able to collect enough high quality vulnerability functions. When you don't have enough data, I don't think you can have a kind of a super AI model to do the good job. So this is actually a real challenge. And at the same time, how to understand the logic, decision logic of the AI model, whether they can really learn the vulnerability or not. So this is also an unknown question because the AI model is a black box. So still a lot of things need to be done in this direction. So that is why now we also have, I think in Singapore, we just set up a new center called Trustworthy AI and Cybersecurity Center in the university. So we have a research team keep working on the AI security and applying AI in the cybersecurity problems. Okay. So I think I don't want to take too much time, but I think this is maybe something interesting. Last couple of slides. I talked so much about the security, open source, but what that this thing to do with me, right? I think these are the maybe some of the questions you can think about. In your software project or your organization, what are the open source library you're using? Do you know any of them? Are they contain vulnerabilities? Do they have any license risk in these open source problems? So if you don't know the answer, that is fine. I think most people don't know this, right? Because you have probably 100 or 200 open source library used in most of the projects. But what I want to say is that this is the part of the innovation we are focusing on is typically security is done by security team, and the development team is running like agile development approach. They want to release the code, if not every day, but every week. The security team, they tell you, okay, I can only do the code auditing every quarter or every half year, right? So there's a big gap between the security demand. So Scantist is the spin-off company. We're doing application security. We want to automate these things. So we want to convert all the research in the university into kind of the tools to help the developer to find and manage their vulnerabilities in their application, right? So in this regard, I don't want to do a sales pitch. So these are the tools I think you can look into them. They basically do the open source management. And they can link with the CI/CD. But this is the part I really want to sell. This is the big vision or the directions we are pushing toward, is to do this kind of open source house profile, or generally any software we think is like a human beings. You should do the kind of health screening every year, right? To understand your cholesterol level, your blood pressure level. This is the same thing for software. So we're trying to define the quality, security, liveness, maintainability, business risk, and development risk, everything from the developer perspective to let you understand what is the things happening in your software. Do you have any high blood cholesterol, and you need to do something or not, right? So this is the kind of the things now we are building. I think this is a very useful things, and I hope this can be part of the future software development to provide more insight about software. So when you are developing software, you can rely on AI to help you. You can build complicated things, but at the same time, you need to have kind of a high-level idea how good, how secure your software is. Otherwise, you may end up spending a lot of time, but you are developing a very risky, vulnerable software, which can potentially jeopardize your business, right? I think that is all. Thank you very much. Yeah.
Okay. Okay, due to the limited time, so we are open to questioning for the professor, and let me take it first.
Sure, yeah.
So the professor, as the developer, we are, so when we have some question, or we prefer to download some code from the GitHub and lots of the website on public. So is there still safe for us to download some code or use some solution on trusted website? Is it still safe?
I think this is the case. So generally, when you're doing software development, people don't worry about security, rather focus on the functionality. I want to build a printing function, right? So I download a PDI printing libraries from open source. I will never worry about security before I'm using any libraries. So what is the things now, the typical practice is that you download all the software, you build your solution, and then you scan using this kind of the things we're offering, like Scantist, this kind of scanning to find vulnerabilities, and then you help to see what are the remediation, how to upgrade to a new version, how to apply the patch to fix this open source problem. So this is the current practice. But the future, what I'm envisioning is that we want to build this secure package manager. So when you are downloading this open source library from this source, you are guaranteed that the library you are downloading have all the necessary security patch. And actually now we are already started building this next generation of the package manager to provide this kind of capability. Yeah. Yeah, thanks.
Thank you for the insightful sharing. So I was wondering if is it possible to combine the capability of ChatGPT with the solution together. Since ChatGPT is you're able to can talk to ChatGPT and then train it, and ChatGPT actually can understand the source code. It can be used to rewrite your code to optimize it. I guess it will have that kind of capability to find bugs. Maybe not all the bugs, but those quite common pattern things.
Okay, yeah, I think this is a very good question, and actually we are doing many related research. We are using AI to find bugs. We are using AI to fix bugs and vulnerabilities. It's called automatic program repairing. This is more technical jargon, but this is the things we're doing. But I share with you the reality is that some of the bugs, they can be very simple. You don't need to use AI to detect it. Very simple AST-based root analysis engine can help you detect it. But some of the bugs or vulnerabilities are very tricky, especially the logic-based kind of vulnerabilities. I don't think AI is ever able to understand your own business logic. So if you are expecting the AI to do this kind of vulnerability detection, it is very tricky. It's very challenging. So somewhere in the middle is the part which AI potentially can be helpful or more effective. So this is the things we are trying now. But in general, bug fighting, vulnerability fixing, this is a very complicated task because it involved understanding about the program logic. It involved understanding about the vulnerability itself. It also potentially involved understanding about the operating system as well as the environment, because vulnerability can be actually related to the environment. So when you have a very complicated scenario which involve all this information and you expect the AI to understand all of them, I don't think AI is ever able to grab the complicated context and at the same time understand the precise root cause of the vulnerability. So this is, I think, the really challenging part. Yeah.
Thank you.
Yeah, thanks.
Okay, thank you. Thank you, Professor.
Yeah, thank you.